Alright, this is Mr. Anderson for Kellogg Community College. We're going to look at some rational expressions in section 8.1. This is on page 481 of the Math 101 book written by Blitzer. And this is going to talk about some situations where we can simplify a numerator and a denominator with something a little bit more complex than monomials. Let's just get into the problems today. We are going to look at problems numbers 49, 59. We're going to also look at problems numbers 69, and on the next page on 482 we're going to look at 73 and number 75. So a bunch of problems today just to go over some basic factoring skills and also some simplifying skills. So let's look at problem number 49. Problem number 49 starts out with a polynomial of 4 terms. This is going to be x cubed minus 2x squared. And then we're going to then take a look at plus x minus 2. And in the denominator, we're going to have just a binomial. That binomial is going to be x minus 2. Now, when we look at our factoring laws, we first of all see if we can remove something from each of these terms in the numerator and denominator. Can't do that. Then we ask how many terms there are. And there are 4 terms in the numerator, so what we're going to do is use factoring by parts. So we're going to take a look at what we can factor out of the first 2 terms, which is an x squared, and that will leave me an x minus 2 factored out of the first 2 terms. Now you might be saying, well, there's nothing we can factor out of the next 2 terms, but we can factor out a 1. And that 1 will factor out and then, excuse me, keep this the same as x minus 2. And that is the key in factoring 4 terms, is that you want to have 2 parentheses look exactly the same. Your denominator will not change at all. Now I'm going to rewrite this down here, but instead I'm going to reorder it using a principle of the distributive property that says I can take my match, which is my x minus 2, and then take my leftovers right there, which is my x squared plus 1. And that is a logical and correct way to rewrite this this setup here using a reverse form of the distributive property. Then in the denominator we got x minus 2. Cross those out, and so our answer here is x squared plus 1 as my simplified form of this problem. Bear in mind that this is true for all values of x where x is not 2, because if I plug 2 in for this x, I would get a division of 0 error. Alright, let's move to problem number 59. Alright, let me move up my sheet here. Okay, so in problem number 59, we're starting off with x minus 5 over 5 minus x. Now what I'm going to do is give you this little trick here, because it doesn't seem like there's anything you can do. You cannot crisscross or simplify any part of this. Like you cannot just cross out the x's or cross out the negative 5s. The rule is you can only simplify if the numerator binomial and the denominator binomial match exactly. So here's what we're going to do. We're going to factor out a negative 1. Now what happens when I factor out a negative 1, it takes whatever numerator or denominator and turns this positive x to a negative x, and this positive 5 to a negative 5, or negative 5 to a positive 5. What that means is that I now have this in the numerator, and then this in the denominator. And I'm writing out my steps pretty well longhand because I can show you that I can reorder this using the commutative property. And the commutative property says that I can order around addition any way I want. So that is going to be 5 minus x, and in the denominator also 5 minus x. And here we have simplification right there, and so our answer is negative 1. Now another way to do this problem is you could have actually taken a negative 1 out of the denominator, and you would have 1 over negative 1, and if you get an answer of 1 divided by negative 1, your answer is still going to be negative 1. And that's if you took the negative 1 out of the denominator instead of the numerator. So just as a little quick trick, if you ever see this type of setup where you have the opposite order, factor out a negative 1 and it will take care of that problem. And you're going to see that in the next couple of examples here. Let's look at problem number 69. problem number 69 is going to start out with the numerator x squared minus 1, and the denominator is going to be 1 minus x. The numerator is going to be x plus 1, x minus 1, because of the difference of squares. That was a pattern that we learned in the previous chapter. You can't factor anything out of this problem as it is, and this is a binomial, so therefore you look for difference of squares. 1 and 1 are both perfect roots, and also it's a difference, and this is an even power, so you can do the difference of squares. Now down here, we're going to do the same thing again. We're going to pull out a negative 1, and in this case we're going to reorder it just to save ourselves a step. And then we can do some simplification. Now you'll notice that I say the word simplification. I don't like saying the word cancel. Nothing actually cancels. This divided by this is 1. There's actually nothing that cancels. It's just kind of a lazy word in how we've been doing in teaching mathematics. And there we have our answer, but that's not the way that the answer is actually written in the back of the book. Nor can we can actually simplify this, because you can divide this and this by negative 1, or to show you what I'm talking about here, since this is a monomial, this is a legal step here, where we can take each of the terms in the numerator and divide it by this in the denominator. So this gives me an answer of negative x minus 1, which is what's in the back of the book. So yeah, there's a lot of different ways to do this problem. Some of you might be thinking about this like, well, I pulled the negative 1 out of the numerator, and that's why I got the negative 1 up there. And yeah, there's more than one way to do this problem, but it does always simplify to this answer at the end. All right, we got 2 more problems to go. We got 73 and 75. So let's go take a look on page 482, problem number 73. All right, and let me center this on my sheet here. All right, 73 starts out with x squared y minus x squared. Gee, do you see something we can take out of the numerator? And the denominator is x cubed minus x cubed y. You see something we can take out of the denominator? All right, well, the first rule of factoring is that we got to look and see what the numerator or denominator has in common. And in this case, it's an x squared. And that would leave, when I pulled an x squared out, it would leave me y minus 1. And then in the denominator, I have x cubed. If I factor that out, it would leave me 1 minus y. Okay, so with that in mind, we have this on the top, we got this on the bottom. So we're going to do some simplification. You'll notice that these are that little order sharing problem. So I'm going to pull a negative 1 out of the numerator. So if I pull a negative 1 out of the numerator, it makes negative 1 times x squared, which is negative x squared. And now I've got my 1 minus y, because it will then match my denominator, 1 minus y. Divide those two right there, and that makes a 1. Now, remembering my rules of powers, if I have x squared over x cubed, I subtract my exponents. This is x squared divided by x cubed, and this leaves me with just 1x in the denominator. Hey, Rachel, how you doing? Good. Good. I'm just teaching a lesson here. So what that leaves me with is, hold on a second here. If I have 1x in the denominator, it's going to leave me negative 1 over x. The negative can actually go anywhere. So for some of you who pulled a negative 1 out of the denominator, you could have had 1 over negative x. In fact, the book writes the negative in front. But they're all equivalent answers. 1 over negative x and 1 over x with a negative in front, all of these are the same things. Now, this is the standard way that most books and textbooks will write it, but you can see all 3 of these, and they're all technically equivalent. All right, let's move to the last problem here, 75, while my daughter gives us some background music. All right. Enjoying your cookie? Mm-hmm. Yeah, it's a good cookie. All right, so... You need to leave Dad alone. I didn't know he was doing that. It's okay, it's okay. Is there a little honey on your... Yeah, just a little bit. This last problem here... Oh, thank you, Ann. This last problem here is we're going to take a look at factoring this somewhat complicated trinomial in the numerator, and in the denominator of this, just to make things even worse, check out this trinomial in the denominator. This is complicated factoring, and it's probably at least not so bad because we don't have as many choices to go through this bottom part here. All right, and sorry for my handwriting right there, but look at that numerator. Woo. Yeah, this numerator is a trinomial, and as explained in the previous chapter, when you have x's and y's in the same space, you're going to have an x plus y situation, x plus y. So you're going to have x's and y's, two pairs of them because of the x squared and y squared there. Now, this is a simplified factoring. Since you have a 1 in front of the x, you just have to ask yourself what two numbers multiply to make -3 and add to make 2. Well, the two numbers that multiply to make -3 and add to make -2 is -1 and, -1 and +3. So that will mean that my x and x are going to be both 1s, and I'm going to have a -y and a +3y to give me my 2y in the middle. And if you do your FOIL, you can then verify that that's correct. Now we're going to move to the bottom one. Oof, this is going to be rough, because here it's not simplified factoring because this has a 1 and 2 in front of it, and this is either -1 and 3 or -3 and 1. Which combination of 1 and 2 makes a 5 in the middle with a 3 and -1 or a -3 and 1? So I know that's right. Which one gives me the 5? Oh, 2 times +3 is 6, and 1 times -1 is -1, so there's your combo. So here it is. I'm going to put my 1 times -1 plus 2 times 3, and that gives me the 5 in the middle. So this is my correct combo. Now here's the tricky part. The tricky part is putting that in the correct order here. Both of them have an xy, and here's where things get fun. I got my 1x and my 2x. I don't usually write the 1 in front of the x. And then I've got my 2 and my -1 and my 3. Where am I going to put those? Well, from the hint that we learned earlier, 2 times 3, it has to be in the other parenthesis. Since the 2 has to get multiplied by the 3, technically with the eye of the FOIL cable, they have to be in separate. So these two have to be in separate parentheses, and these two have to be in separate parentheses. So my -1 is right there. So it looks like I get to do some simplification right there and there. So I've got my final answer of x minus y over 2x minus y. Whew, yeah. No wonder they don't leave this problem for number 75 for nothing. That is a big problem. And if you have more questions, just bring them to class or shoot me an email. Thank you.